So p-value is the probability or area below the graph of your standard normal distribution of obtaining a sample statistic as extreme as the one given in the question or in the example, and level of significance denoted by alpha is maximum allowable probability. Again, you have a probability. It means that you are working with area of making type 1 error. We reject the null hypothesis if P, the area, is less than or equals to alpha. Alpha or level of significance is another area. We fail to reject the null hypothesis if p-value or the probability is greater than alpha. So what are the steps?
I have a question. When we
So let's erase this. Okay, let's use our. So I'm going to use different side. I'm going to write down the steps. So, hypothesis testing for the mean when sigma is given. Hypothesis testing for mean when sigma is given. What was the first step? So, like before, we're going to divide it up. Let me use this one. Here we go. So, hypothesis testing for the mean mu sigma is given. First, step one, you have to check to see if n is greater than or equals to 30 or population is normally distributed. N is greater than or equals to 30 or population is normal. What's the second step? Step two. Step two. Null hypothesis, alternative hypothesis. How many cases do you have?
3.
3 cases. Very good. What was the first case? Mu is?
Greater than or equal to k.
Very good. And its complement, its opposite, mu is less than k. What type of graph do you have? Left tail, right tail, two tail, which one is that?
Left tail.
Left tail, thank you. We look at our alternative hypothesis. Left tail.
it's not good. Oh, you see.
Left tailed. Second case, H naught says mu is less than or equal to k. Its opposite, mu is greater than k. What type of graph?
Right tail.
Right tail. Excellent. Well done, everyone. Right tailed. And finally, So we have or mu is equal to k, its complement, mu is not equal to k, which is
Two
Two
type.
tail.
two-tailed graph. Excellent. Two-tailed graph. Some part of the area on the left, some other part is on the right. Two-tailed. So let us write them here. So these are actually, for these two are going to be the same. So I'm going to just space this up nicely, since we're just going to repeat the same thing for both of them. Okay. Step 2, we need to identify null and alternative hypothesis. H naught, mu is greater than equals to k, HA, mu is less than k. Here we get a left-tailed graph. Or your null hypothesis says mu is less than equals to k, HA, mu is greater than k. It means that you have a right-tailed graph. Or here you have a two-tailed graph. Null hypothesis says mean is equal to k, its complement, mu is not equal to k. Two-tailed graph. What's the next step? Identify.
Level of significance.
Excellent. Identify level of significance or alpha. 3. What is alpha? What is alpha? Next step. Find the standardized test
Statistic.
statistic. Very well. So, what was the formula?
Z equals mean minus mu
Excellent. Divided by
sigma.
sigma over. We flip that. X bar minus mean divided by sigma times square root of n.
N.
So, test statistic. Standardized test statistic. Z is X bar minus mean divided by sigma times square root of. Next step.
Find the area.
Very good. Find the area for our Z. So step 5. You are either using your Z table or using your calculator. It doesn't matter. And then next step, Find what? Next step, guys. What is our next step? Find p-value. So your goal is to compare p-value and your level of significance, alpha. So we need to find p-value. How do we find p-value? P-value is, if you have a left-tail graph, p-value is that area. Area to the left, or if you have a right-tail graph, what's the p-value? Area in the right What if you have a two-tailed graph? What is the p-value? Two-tailed graph, 2 times area in the tail. 2 times area to the left. Again, guys, this is very important. If you have a left-tailed graph, area to the left. If you have a right-tailed graph, area to the right. If you have a two-tailed graph, 2 times the area to the left. So since we're going to repeat this for both of these, or all of these actually. It's a little bit up. P is equal to area to the left. For this guy, P value is area to the right. And for two-tailed graph, P is 2 times area to the left. Super important. And finally, if P, last step, if P is less than equals to alpha, we reject the null hypothesis. If P is greater than alpha, we fail to reject the null hypothesis. Last step, if P is less than equals to alpha, reject the null hypothesis. If P is greater than alpha, fail to reject the null hypothesis. Perfect. Page 2, example. Finding a p-value for a left-tailed test. Question says, find the p-value for a left-tailed hypothesis test with a standardized test statistic which is given to you as z equals to minus 2.23. Decide whether to reject the null hypothesis when the level of significance alpha is given as 1%. There you go. Since z is given, p-value is the area to the left of z. The area to the left of z is your p-value. By using your calculator, you get 0.0129. Let's take a look at our calculator. Turn on the calculator. Second bars. So normal CDF. On the left-hand side, you have negative 100 upper limit, negative 2.23, so minus 2.23, mu is 0, sigma is 1, and let's calculate that. The p-value is 0.0129. This is your p-value.
Can you repeat again?
Sure. So z is given to us, negative 2.23. We want to find the p-value. We learned p-value is the probability, the area to the left of z, the given z. So we go to second, bars, normal CDF, lower limit, negative 100, negative 1,000, a very small number on the left-hand side. Upper limit, you enter your z value, which is minus 2.23. Since it's a z value, mu must be 0 and sigma must be 1. So let us paste, calculate. We get the area on the left side, which is 0.0129. This is your p-value. Okay.
But what is different? I normally use a CDF.
If p is less than equals to alpha, then we reject the null hypothesis. So now that we calculated our p, which is 0.0129, is this less than equals to alpha? Alpha is just 1%. So is 0.0129 less than 0.01? Of course not. This is greater than. So do we reject the null hypothesis? We fail to reject the null hypothesis. One more time. We have our z. We use our calculator. To find p, which is the area to the left. Now that you have your p, you check to see if p is less than equals to alpha or not. If p is less than equals to alpha, we reject the null hypothesis. If not, we fail to reject the null hypothesis. In this example, we found p to be 0.0129, which is not less than 1%. So we fail to reject the null hypothesis. So our next example says, finding a p-value for a two-tailed test. So here you have a two-tailed test. As you can see, your graph has two shaded parts on the left, on the right. Question says, find the p-value for a two-tailed hypothesis test with a standardized test statistic which is given to us as z 2.14. Z is given to us. We need to find p-value. To find p-value, we find the area to the right or to the left, it doesn't matter, of our z, then multiplied by 2. Because some part of it is on the left-hand side, the symmetric, the exact same portion is also on the right-hand side. It has 2 exact pieces. So let us use our calculator to find one of these areas. Since I have z equals to 2.14, turn on your calculator. Second, vars, normal CDF, z is 2.14 and up. So your lower limit is given 2.14. The upper limit, you can use any positive number. Let us write 100. Mean is 0, sigma is 1. Let us calculate that. This is 0.0162. So this little portion, this little area is 0.0162. This is just half of the area. 2 areas altogether is 0.0162 plus 0.0162, or 2 times 0.0162. So your p-value is equal to, p-value is equal to, you can write it as 2 times 0.0162, or you can just add these two together, it doesn't matter. P-value is equal to 0.0324. We used our z to find this little area on the right-hand side. Now you add these 2 little areas together to get the p-value. Now you have to make decision. Is p-value less than equals to alpha, or is it greater than alpha? If p-value is less than equals to alpha, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. P-value is 3%, 0.0324. What is our alpha? Alpha is 5%.
Less.
Very good. Yes, it means that we reject the null hypothesis. This is our conclusion.